So welcome to your new video. So basically we completed acidification, we are going to start acidification. We have completed the countercurrent mechanism. Okay, so in acidification of urine, so basically what is acidification of urine? So basically acidification of urine is basically secretion of H plus in tubular lumen and reabsorption of bicarbonates in renal interstitial fluid. Okay, secretion of H plus or reabsorption of renal interstitial fluid. So basically this acidification kind of thing, I told you in the previous video, we completed the whole nephron. Basically this acidification of urine should be discussed separately, as it is a little important topic, and if I teach this acidification of urine in between that PCT cell and kind of thing, it will disturb our flow, and it will be not productive, you will get confused in other kinds of thing. So basically we studied about glomerulus, then the PCT, then loop of Henle, DCT. Acidification of urine basically occurs in PCT, occurs in tubular system. Now basically what are the components of the tubular system of the nephron? They are the PCT, the two limbs of the loop of Henle, and then the DCT, and also the collecting tubule. So remember, acidification of urine or secretion of H plus and reabsorption of HCO3 minus occurs in tubular system. So tubular system, the first tubular system and the last tubular system. Okay, first and last. Don't write it like first and last, it is the trick to remember. Okay, so first is what the component of the tubular system, which is the PCT, and the last is, yes, the collecting tubule. Okay, so now we will see how does that acidification occur. Okay, so imagine this is the tubular cell or the PCT cell. Okay, PCT cell, this is the tubular cell. Okay, this brown color structure. On my right side it is the tubular lumen, and on my left is the interstitial fluid or the renal interstitial fluid. Now PCT is the first structure. Okay, so since it is the first structure, all the components which are present in the urine, okay, mark my words, all the components are present in urine after glomerulus except proteins, they will be present here in the PCT. Okay, so sodium, glucose, then the other electrolytes, water will be present. So first I will write sodium. Okay, so basically Na plus is present, and also along with Na plus the HCO3 minus is present. Okay, NaHCO3 basically, but Na plus and HCO3 minus present in the ionic form. Now what happens is, this Na plus, okay, it goes to the cell. Okay, the pump. Okay, the Na plus H plus pump. Okay, the Na plus H plus pump, and further with the help of the ATP kind of thing, this Na plus is back to the renal interstitial fluid. This will be K plus. Okay, now from where does this H plus came? So we will study this HCO3. Okay, so what happens is, this HCO3 and H plus combines to give H2CO3. Now this H2CO3 will further break, as you know, in which compounds? it is H2O and other is CO2. Okay, now this H2O and CO2, they come here in the cell. Okay, so basically H2O plus CO2. Now with the help of that enzyme, which was that enzyme which was combining, yes, Ca, carbonic anhydrase, this H2CO3 formation will occur. This H2CO3 further will, like, it will dissociate into H plus. Okay, I am writing it like this, just a second, this K plus. Now what is the product of H2CO3? Yes, HCO3 minus. Then this HCO3 minus, it is passively reabsorbed, and the H plus which is seen, it is this H plus. Okay, basically NaHCO3 is present in tubular lumen. For first discussing about the HCO3, the HCO3 first combined with H plus, which has come out with the help of NaH pump. This H2CO3 will further dissociate and go into the tubular cell. This tubular cell, with the help of the enzyme of carbonic anhydrase, will convert this into H2CO3. This H2CO3 will further dissociate into H plus and HCO3 minus. Then this H plus will be secreted in the tubular lumen in return of Na plus, and this HCO3 minus is passively reabsorbed. So this was the acidification of urine in the PCT cell. So basically H plus is in the tubular lumen. So now acidification in the tubular lumen occurs. Now in collecting tubule, how it is in collecting tubule? So tell me, when talking about the collecting tubule, not many ions or many items come in the collecting tubule. Okay, so the tubular cell itself contains H2O. Okay, and CO2 is gained from the cells, like the CO2 is gained from the other cells, like due to their metabolic product as CO2. The CO2 comes in the cell. Here also the CO2 is obtained from metabolic product. Okay, now this CO2 combines with H2O, okay, to give H2CO3. Then the same story, the SCO3 minus plus H plus. Okay, now what happens is the the HCO3 minus, okay, so basically the HCO3 minus go in the renal interstitial fluid, okay, in exchange of Cl minus, and this Cl minus is passively secreted in the tubular lumen. Okay, now this H plus, with the help of primary active transport, okay, this requires ATP, it is secreted in the tubular lumen. So this was all about the acidification in the collecting tubule. Okay, so since H plus ions, let me just write it, H plus ions are present in tubular lumen, the tubular lumen becomes acidic. Now tell me one thing, the tubular lumen consists of H plus ions, so it is acidic. So if there is much more H plus excreted in the tubular lumen, there should be a threshold. Okay, so basically the threshold, note, threshold for H plus, you should remember two values. So the first value is 4400 milli equivalent per day, and the second value is at pH is equal to 4.5. okay, so 4400 milli equivalent per day, this is the value. Now tell me one thing, what will happen if the H plus is beyond this limits? Okay, let's say the H plus is 6000 milli equivalent per day, or the H plus is 5000 milli equivalent per day, or it crosses the pH 4.5, like it is more acidic. So I will just mention pH is equal to 4.5. This means pH should be more than 4.5. okay, so basically below this pH, what will happen? So basically what happens due to this, the H plus excretion ceases. Okay, so let me just write it here. Below 4.5 pH, below pH of 4.5 or above 4400 milliequivalent per day, it will lead to cessation of H plus excretion. So tell me one thing, if cessation of H plus occurs, cessation of H plus excretion occurs, what will happen? The metabolic acidosis. But to avoid this metabolic acidosis, we have the buffers. Okay, what does buffers do? When the H plus concentration, like it gains a higher value than 4400 milliequivalent per day or a lesser value than 4.5 pH, that means it is more acidic, this buffer basically perform the excretion of H plus. There this procedure doesn't occur till that acidosis is not covered. Okay, so basically what happens, if for example there is much more acid in your body, like your H plus concentration in our body is increased, so we have to remove that H plus, but as it is crossing the daily limit value and also the pH is lower than expected, so what happens is this buffers take over the job of excretion of H plus. Okay, so we basically have buffers. The name of the buffers, just a second. A phosphate buffer is present. Okay, and ammonia buffer, and again ammonia buffer. So what is this? I will explain you, just a second. Okay, so why this two ammonia buffers? So basically one operates in the proximal tubules. Okay, proximal tubules, and another operates in the collecting tubules. And this phosphate buffer, it occurs nearly everywhere. Okay, so now starting with the phosphate buffer. Okay, let me just, like, I will draw the diagram and I will come in a minute. Okay, so now starting with the, just a second, the phosphate buffer, starting with the phosphate buffer. So basically in the phosphate buffer, the buffering substance is the NaHPO4 minus. Okay, it is present along with Na plus. So just a second, Na plus plus NaHPO4 minus. Now remember, while writing about phosphate buffer or ammonia buffer to be specific, that in collecting tubules, okay, the ammonia buffer, the phosphate buffer, basically we will start from the inside of the cell. Okay, so the inside of the cell is simple, so we'll start it from there. H2O plus CO2, the commonest procedure. CO2 is coming from the interstitial fluid. Okay, metabolic processes. H2CO3. Now with the help of enzyme carbonic anhydrase, the HCO3 minus plus H plus. Okay, now we have Na plus, we have H plus, so it is simple, NaH pump. So basically this H plus will go outside, will be secreted, this Na plus will come inside. Okay, so now this H plus will combine with this and it will be NaH2PO4. Okay, minus, it will not minus anymore, so So basically this happens in phosphate buffer, okay, the H plus secretion. Also we have to reabsorb the HCO3 minus. So what happens? Passive reabsorption. I will show in a dotted line. Passive reabsorption of HCO3. And what happens to this Na plus? This Na plus, what happens? So basically we have the ATP based Na and K pump, okay, Na plus K plus pumps. So basically we have done H plus excretion by the help of NaH pump, and we have done the reabsorption of HCO3 minus passively. Okay, so start from inside. First write the products which are outside the like cell in the tubular lumen. So the main buffering substance is NaHPO4 minus along with Na plus. So basically the Na plus is reabsorbed and NaHPO4 combines with that H plus, which is secreted by the tubular cell, and it leads to formation of NaH2PO4, and this NaH2PO4 further is excreted. Now the ammonia buffer. Now I have told you, like actually I was mistaken there in previous segment. Like in the proximal tubule itself it is a little different procedure, but for others you should start from inside, like H2O and CO2, H2O plus CO2, and then that procedure. But for ammonia buffer, which is in the proximal tubule, it is a little different. Okay, so what is the difference? Let me see. Okay, so what happens, basically there inside the cell there is glutamine. Okay, and what is glutamine? Yes, it is a storage form of ammonia. Now if the glutamine breaks, it will give two products. Remember, one will be NH4 plus, okay, and 2 NH4 plus and 2 HCO3 minus. Simple as that. And this HCO3 minus, passive reabsorption. Okay, now our job is done. Okay, the HCO3 minus is reabsorbed, so the acidosis might be covered. Okay, like it can be compensated. Now what happens to this 2NH4 plus? Okay, so now these NH4 plus, basically it have a pump. Okay, this pump is NH4 Na plus pump. This is one of the different pump. Okay, so one NH4 out of the lumen. Okay, so basically it will be NH4 plus and one Na plus in. Okay, so Na plus. Now from what will be this NH4 kind of thing? So basically what happens, glutamine, this NH4 will be basically it will be excreted. Okay, now from where does this glutamine came? So basically the glutamine itself come from the tubular lumen. Okay, so here buffering substance is glutamine plus Cl minus. Okay, let me just highlight the buffering substance here. Okay, Na plus plus NaHPO4 minus in the proximal tubules, not the proximal tubules, the phosphate buffer nearly seen everywhere, and in the proximal tubules of the ammonia buffer, the glutamine plus Cl minus is the buffering substance. So basically this is one of the different kind of thing. Now what is excreted? So basically NH4Cl minus and Cl minus is excreted. Cl minus comes from here. So this was all about the ammonia buffer, proximal tubules. Okay, so this is a little different one. Glutamine is in the tubular cell. It splits to give HCO3 and NH4, two molecules of each. That HCO3 is passively reabsorbed as usual, and this NH4 in turn of 1 Na plus 1 NH4 is sent out. Then glutamine plus Cl minus is the buffering agent. That glutamine comes from the tubular lumen itself in the cell, and that Cl minus gets excreted along with that NH4 plus. This was all about the ammonia buffer. Same diagram for the ammonia buffer, distal tubules, or sorry, it should not be distal tubules. It is the collecting duct. Okay, it is a collecting duct. Now repeat the same story. Okay, H2O plus CO2 will give you H2CO3. This H2CO3 will further give H plus HCO3 minus in the presence of Ca carbonic anhydrase. As usual, this HCO3, let me write it like this: HCO3 minus plus H plus. This HCO3 is passively reabsorbed. Okay, now what is the buffering agent here? Now the buffering agent here is NH3. And from where does we get this NH3? So we get the NH3 from that cell itself, tubular cell. Like from metabolism, we excrete that NH3 plus. The buffering agent is NH3 minus, sorry, the NH3. So the NH3 is passively secreted and gone into the tubular lumen. So NH3 comes here. The tubular lumen already contains Cl minus. Okay. Now this H plus. Okay. Now there's no way of transporting that H plus. Okay. So what does we will do? So basically, active transportation of H plus. The S plus is actively transported with the help of ATP. Only H plus is thrown out, and this H plus, let me just change the color. H plus further combined with NH3 makes it NH4 plus along with Cl minus, and they are excreted in the urine. Okay, and the CO2 is obtained by renal interstitial fluid, the metabolic processes, the metabolic product. Okay, we have completed the buffers. So phosphate buffer, what happens in phosphate buffer? Basically we get CO2 from the renal interstitial fluid. Okay, so this H2O plus CO2 combines to give H2CO3. Okay, this H2CO3 further breaks. The H plus is in turn like the buffer. The buffer is basically Na plus plus HPO4 minus. So that Na plus is exchanged by H plus. The NaHPO4 combines with this H plus and then give rise to a product named as NaH2PO4. Then HCO3 minus is passively reabsorbed. Now in the ammonia buffer, the proximal tubules, what happens is glutamine breaks, gives rise to 2HCO3 minus 2 NH4 plus. This NH4 plus basically is exchanged by Na plus 1 NH4 1 Na plus. HCO3 minus is passively reabsorbed. Where does where does this glutamine comes? Glutamine comes from the tubular lumen. Glutamine plus Cl minus. This Cl minus combines with NH4 plus and it is excreted in urine. Now the ammonia buffer, the collecting duct. Okay, now what happens? There the H2O plus CO2, H2CO3, H2CO3, HCO3 plus H plus. Then H plus, the phosphate, like the buffer is NH3 and Cl minus. Okay, so it exchange, like active transport occurs of H plus. Only H plus is thrown out. NH3, the buffering system, like the buffering system is this one. Let me just highlight it. NH3 and Cl. So this NH3 combines with H plus, gives NH4 plus and Cl minus. This NH4 plus further it is NH4 plus and Cl minus is further excreted and the CO2 is gained from the renal interstitial fluid. So tell me one thing, what you have learnt in this lecture. This is the physiological mechanism, acidification of urine in PCT cell. Okay, like what happens? The H2CO3 wala procedure. Then the Na plus HCO3 minus is present. Na plus is exchange for H plus. Na plus is exchange for K plus. H plus combines with HCO3. This H2CO3 breaks H2CO2. Then it is further taken back to the tubular cell. In the collecting tubule, okay, what happens? Cl minus, the H2CO3 wala procedure. HCO3 exchange for Cl minus. H plus active transport. Okay, then Cl minus. Now the Cl minus is passively excreted and HCO3 is exchanged for it. So the normal procedure, if threshold is crossed, then this phosphate buffer, ammonia buffer comes in action. Okay, So basically the applied point will be discussed further in a separate video. Okay, we have yet to learn the micturition reflex and some of the applied aspect. So that's it for the today's video. Thank you.